Our planet's story begins approximately 4.5 billion years ago. Imagine a vast cloud of gas and dust, remnants of an exploded star swirling in the cosmos. This is the solar nebula, the birthplace of our solar system. Gravity drew these particles together, pulling them into a spinning disk. At the center, our sun ignited, bathing the surrounding disk in light and heat. Within this swirling disk, dust and gas collided. Over millions of years, these collisions led to the formation of larger and larger bodies called planetesimals. These planetesimals, drawn together by gravity, continued to collide and coalesce. This process of accretion eventually led to the formation of Earth, a hot molten ball of rock. The early Earth was a chaotic and inhospitable place. Bombarded by asteroids and comets, its surface was a molten sea of magma. Volcanoes erupted violently, spewing lava and gases into the primitive atmosphere. This period of intense heat and bombardment played a crucial role in shaping the Earth we know today. It's hard to believe that this fiery, chaotic ball of rock would eventually evolve into the vibrant, life-sustaining planet we call home. But as we'll see, Earth's journey is one of constant change, a testament to the power of time and the remarkable resilience of life itself. As millions of years passed, the relentless bombardment from space began to subside. The Earth, no longer subjected to constant impacts, started to cool. As the molten rock cooled, it solidified, forming the first solid crust on Earth's surface. This marked a significant turning point in our planet's evolution. The early crust was far different from the continents we know today. It was a patchwork of thin, unstable plates floating on the semi-molten mantle below. Volcanic activity was still rampant, with eruptions shaping and reshaping the landscape. This dynamic period laid the foundation for the continents and oceans that would come to define our planet. The cooling of Earth also led to another crucial development: the outgassing of volatile compounds trapped within the planet's interior. These gases, released through volcanic eruptions, formed the basis of Earth's early atmosphere. This primitive atmosphere, however, was very different from the air today, lacking oxygen and dominated by gases like carbon dioxide, methane, and ammonia. The formation of the crust and the release of gases from Earth's interior were crucial steps in transforming our planet from a fiery inferno into a more hospitable environment. The stage was set for the next chapter in Earth's story, the formation of oceans and the emergence of life. With the Earth's crust cooling and solidifying, the stage was set for another dramatic transformation, the formation of the atmosphere and oceans. Water vapor released from the planet's interior through volcanic outgassing began to accumulate in the atmosphere. As the Earth continued to cool, this water vapor condensed, forming clouds and leading to the first rains. Over millions of years, these rains poured down upon the cooling crust, filling the low-lying areas and forming the first oceans. These early oceans were likely acidic and hot, a stark contrast to the vast, life-filled oceans we know today. While the oceans were taking shape, the atmosphere continued to evolve. The outgassing of volcanoes released more gases, including nitrogen, which would become the most abundant gas in the atmosphere. However, oxygen, essential for life as we know it, was still largely absent. The early atmosphere, devoid of oxygen and rich in greenhouse gases, played a crucial role in regulating Earth's temperature. It trapped heat from the sun, preventing the planet from freezing over and creating conditions suitable for the emergence of life. The formation of the atmosphere and oceans were defining moments in Earth's history. These two interconnected systems, working in tandem, would provide the cradle for life's emergence and shape the trajectory of our planet's future. The early Earth formed oceans and a primitive atmosphere was a world brimming with possibilities. It was in this primordial soup, approximately 3.5 billion years ago, that life first emerged. The exact details of this miraculous event remain shrouded in mystery, but we know that the first life forms were simple, single-celled organisms. These early microorganisms, known as prokaryotes, were incredibly primitive. They lacked a nucleus and other complex cellular structures. However, they possessed the remarkable ability to replicate themselves and pass on their genetic information. Life on Earth remained microscopic for billions of years. However, these early microorganisms gradually transformed the planet. Through photosynthesis, they harnessed sunlight to produce energy, releasing oxygen as a byproduct. This process, known as the Great Oxygenation Event, had a profound impact on Earth's atmosphere. Over millions of years, oxygen levels in the atmosphere gradually increased. This paved the way for the evolution of more complex life forms that relied on oxygen for respiration. The rise of oxygen was a turning point in Earth's history, transforming the planet from an anaerobic world to one where oxygen-breathing life could thrive. The emergence of life and the Great Oxygenation Event were pivotal moments in Earth's epic evolution. They set in motion a chain of events that would lead to the incredible diversity of life we see today.